Imagine standing inside a steel box in the middle of the ocean, where the walls around you are hot to the touch. The air feels heavy enough to drink. Your shirt is soaked through in minutes. And the only thing waiting for you after a brutal shift is a shower that isn't even cold. Now, imagine doing that not for an hour, not for an afternoon, but day after day, while launching fighter jets, carrying bombs, moving fuel, feeding thousands of people, keeping nuclear-powered systems online, and making sure one of the deadliest warships on Earth stays combat ready. That is life aboard a U.S. aircraft carrier in extreme heat. In places like the Arabian Gulf, the heat index can climb to 125 degrees Fahrenheit, about 52 degrees Celsius. And according to official U.S. Navy reporting, the inside of the steel skin of the ship can feel almost as hot as the flight deck itself. This is not just uncomfortable. It is dangerous. It drains strength, slows reaction times, crushes morale. And if the crew gets it wrong, the heat does not just make people miserable. It starts taking sailors out of the fight. So how do aircraft carrier crews survive inside these floating steel ovens at sea? That is what we are about to show you, and what they endure to keep that ship running will absolutely shock you. Before you can understand the heat, you need to understand the ship. A modern U.S. supercarrier is not just a warship. It is a floating city. The USS Gerald R. Ford represents the first new U.S. aircraft carrier design in 40 years, built to launch everything from unmanned aircraft to heavy strike fighters. Official Navy reporting describes the carrier as a vast self-contained world with firefighting teams, casualty response squads, huge galley operations, and round-the-clock maintenance just to keep life inside the ship functioning. And the population inside that floating city is staggering. Official Navy reporting on Ford describes a combined population of about 4,200 personnel, roughly 2,700 sailors, and 1,500 squadron personnel, all living and working in a dense steel labyrinth of berthings, passageways, galleys, ladder wells, machinery spaces, medical facilities, workshops, and combat systems. Spaces. Now imagine all of that wrapped in steel. Then place it in one of the hottest operating environments on Earth. That is where the real story begins, because a carrier at sea in extreme heat is not just a ship under the sun. It is a giant heat trap. The sun pounds the flight deck. The surrounding air is already scorching. The sea itself can be hot. Inside the ship, equipment generates heat. Airflow becomes precious. Every hatch matters. Every fan matters. Every cooling unit matters. And once that system starts to struggle, the entire ship starts to feel it. Most people think the ocean should cool you down. On an aircraft carrier in the Arabian Gulf, it does the exact opposite. According to U.S. Navy reporting from USS Nimitz, average air temperatures in the Gulf range from 100 to 105 degrees Fahrenheit, while the average heat index reaches 125 degrees Fahrenheit, roughly 52 degrees Celsius. That already pushes the human body into dangerous territory. But the conditions get worse because the region's weather patterns push moisture and heat into the Gulf, creating a brutal combination of temperature and humidity that makes the air feel even heavier. Dust, haze, and blazing sun only make the environment more punishing. And then there is the seawater. You would think the ocean would be the carrier's natural cooling system. But in the Gulf during summer, even the water is hot. Navy reporting says the average water depth there is shallow, and the sea can sit at around 95 degrees Fahrenheit in summer. That means the systems aboard ship that rely on seawater to help cool refrigerant are being fed water that is already far hotter than ideal. That single fact changes everything. Because when even the sea is hot, you are no longer cooling the ship efficiently. You are fighting a losing battle against the environment itself. This is the part that people who have never served aboard a ship almost never understand. Steel does not forgive heat. According to official Navy reporting from USS Nimitz, being made of steel, the inside of the skin of the ship can almost be as hot as it is on the flight deck. Let that sink in for a second. The ship's outer shell, the very thing protecting the crew from the sea, can also turn into a giant heat reservoir. That means the suffering is not limited to the sailors standing on the weather deck under open sun. Follows them below, into the passageways, into the BER things. Into the workspaces, into the machinery compartments, into the laundry. Into the galley, into every little steel compartment where air movement is limited and heat has nowhere to go. And when sailors come down from the flight deck hoping for relief, sometimes there is none. One sailor aboard Nimitz described wringing sweat from his shirt every time he came down from the flight deck, saying by the end of the day he felt like he could fill a bucket with what he had sweated out. Another described how lucky it felt just to get a cold shower, except even that was not truly cold, because the water drawn from outside was already warm. That is what makes carrier heat different from heat on land. On land, you can escape into shade, air conditioning, open space. On a carrier, the heat is everywhere. Above you, around you, inside the walls themselves. Now here comes one of the most surprising truths in this whole story. The air conditioning on a U.S. aircraft carrier does not primarily exist for the crew. It exists for the ship. Official Navy reporting from Nimitz says the primary purpose of shipboard air conditioning is to cool vital equipment and radars. Crew comfort is secondary. In the words of one machinist's mate, they have to keep the radars spinning and the weapon systems cool so the ship can navigate and defend itself. That makes perfect military sense, but it also explains why the crew can still be miserable even on a ship with climate control systems. The cooling plants are working to protect electronics, combat systems, and essential operational spaces first. Meanwhile, the entire ship is under enormous thermal stress. Navy reporting explains that the cooling equipment used aboard Nimitz was designed around a maximum 90 degrees saltwater inlet temperature, with 85 degrees considered ideal. In Gulf summer conditions, the crew was dealing with seawater on 95 degrees, roughly 10 degrees too hot. That extra burden forced the cooling equipment to work harder and longer. And if one air conditioning unit got overwhelmed and shut down, other units had to pick up the load, creating what sailors described as a domino effect. That is why something as simple as a hatch becomes a big deal. A sailor leaving a hatch open is not just letting in warm air. He may be raising the temperature of an entire space by 10 to 15 degrees. According to Navy reporting, on a ship like this, survival in the heat comes down to tiny habits repeated by thousands of people. Shut the hatch. Protect the boundary. Keep the cool air where it belongs, because if the cooling chain breaks, the heat spreads fast. Not everyone aboard the carrier suffers equally. Some jobs are brutal. Others are almost inhuman. Official Navy safety guidance specifically warns that high heat and humidity aboard carriers can be found in engineering spaces, galleys, sculleries, laundries, and weather decks in hot climates, especially during flight deck operations, exercises, and drills. Think about that combination for a second. On the flight deck, sailors are exposed to direct sun, reflected heat from steel, the thermal punishment of jet operations, and the physical stress of moving fast in protective gear. Below deck, Engineers work around machinery in spaces where heat builds and airflow can be limited. In the galleys and sculleries, crews are surrounded by steam, hot surfaces, and endless labor preparing food for thousands. In the laundries, heat and humidity stack on top of each other until the space feels like a boiler room. These are not occasional discomforts. These are work environments. Environments where people are expected to stay sharp, move quickly, handle equipment, follow procedures, and make decisions that affect the safety of everyone around them. The Navy is brutally clear about what heat does in these conditions. It reduces physical performance, lowers morale, impairs mental alertness, increases accident risk, and can even triple manning requirements in certain spaces because people must be rotated out more often. That is why surviving the heat is not just about comfort. It is about keeping the ship combat effective. When the heat starts beating the crew, the numbers get ugly fast. Official Navy reporting from USS Nimitz revealed that in just a 10-day span, the ship recorded 12 heat-related injuries. The ship also lost 270 man-hours to heat injuries. That is 270 hours of lost readiness aboard one of the most powerful warships on Earth, not because of enemy action, but because of the environment, and the danger is not theoretical. The Naval Safety Center warns that severe heat stress can lead to heat rash, heat cramps, heat exhaustion, and in the worst case, heat stroke, where the body fails to regulate its own temperature and can no longer cool itself. The symptoms can include confusion, delirium, fainting, seizures, and a body temperature of 106 degrees Fahrenheit or higher. Untreated heat stroke can kill. That is what the crew is fighting, not summer discomfort, not a rough day at work. They are fighting a physiological enemy that can silently erase judgment, weaken coordination, slow reflexes, and collapse a sailor before he even realizes what is happening. And because a carrier is a high-risk industrial combat environment, even a small drop in attention can become catastrophic. One delayed move on a flight deck. One missed procedure in engineering. 1 dizzy step on a ladder well. 1 second of confusion in the wrong place. That is why the Navy treats heat as a readiness threat, not just a health issue. So how do they survive? The answer is not one big heroic solution. It is dozens of disciplined little ones. First, hydration. Navy reporting from Nimitz says the recommended intake in these extreme conditions is a quart of water per hour. That is not optional. That is survival. And sailors are warned not to rely on thirst as a signal, because by the time you feel thirsty, you are already behind. Second, food. One of the most surprising lessons reported by the ship's industrial hygiene officer was that many heat stress casualties were linked not just to dehydration, but to sailors not eating enough. Without regular meals, the body struggles to maintain energy and replace what it loses through sweating. Third, uniform adaptation. To help sailors cope, Nimitz modified uniform rules in the heat. Sailors were allowed to wear coveralls half-mast, tied around the waist, and flight deck jerseys did not need to be worn unless sailors were actually on the flight deck. That is not casual relaxation. That is the Navy deliberately reducing heat load where it can. Fourth, recovery spaces. Chairs were set up on mess decks, so sailors from non-air-conditioned spaces could cool down before returning to work. Ice buckets were filled from the galley for cold water before it warmed up again. Some sailors even rigged USB-powered fans in there. Racks just to create a tiny bubble of relief in berthing. This is how survival really looks aboard a carrier. Not dramatic speeches, not superhuman invincibility, just thousands of exhausted professionals doing every small thing right so the heat does not win. but the U.S. Navy does not rely on willpower alone. It fights heat with science. The Naval Health Research Center developed the Automated Heat Stress System, or HSS, to improve shipboard heat monitoring. This system measures environmental conditions by factoring in air temperature, black globe temperature, and relative humidity, then automatically calculates physiological heat exposure limits, which tell the crew how long personnel can safely remain in a workspace before they need relief. Before this system, sailors had to walk through each hot workspace manually taking readings, a process that could take 3 hours on a destroyer. With a HSS, shipboard personnel can get heat stress data across affected workspaces within seconds. That may sound like a technical detail. It is not. It is a life-saving capability. Because on a carrier in extreme heat, the difference between a safe stay time and an unsafe one can be the difference between a sailor returning to work or collapsing. And the Navy knows that heat injuries are not just random. The Naval Health Research Center reported that in 2013 alone, there were 324 cases of heat stroke and more than 1,700 other heat injuries among active duty service members. That is over 2,000 warfighters removed from duty, temporarily or permanently, by heat alone. So when a carrier fights heat, it is not fighting comfort loss. It is fighting lost manpower, lost readiness, lost operational capacity. Now here is the part most people never see. The heat is not just physical. It is psychological. Official Navy safety guidance says, sustained high temperatures lower morale and impair mental alertness. That sounds mild on paper. In real life, it means irritability, slower thinking, poor patience, and that awful drained feeling where every task feels heavier than it should. And aboard a carrier, there is no real escape. You can finish a brutal shift on the flight deck and go below, only to find your space warm, your shower warm, your rack still sticky from yesterday, and your body sweating again before it has fully recovered. You can sleep beside hundreds of other sailors in a berthing compartment and wake up still exhausted. You can start your next watch, knowing the heat is waiting for you exactly where you left it. That kind of environment wears people down, and yet the crew keeps going. They keep eating, hydrating, rotating, checking on each other, shutting hatches, protecting cooling boundaries, maintaining fans, maintaining air conditioning plants, watching for the first signs of heat injury in themselves and in everyone around them. That is what survival looks like when the enemy is temperature. So when you see an aircraft carrier on the horizon, steel hull cutting through the sea, aircraft lined up on deck, radar turning, flags snapping in the wind, it is easy to admire the size, the power, the intimidation. But what you do not see is what the crew is fighting inside. The heat in the Gulf, the humidity, the steel walls storing warmth like an oven, the hot seawater undermining the cooling systems, the shirt you can wring out, the warm shower after a hot shift, the fan in the rack, the quart of water every hour, the sailor who has to be pulled out of a space before heat stress turns into heat stroke. That is the hidden battle of life at sea. And maybe that is what makes it so impressive. Because these sailors are not just serving aboard one of the most dangerous workplaces on Earth. They are serving inside a machine that, in the worst climates on the planet, becomes a furnace, and they still keep it flying, feeding, fighting, and moving forward. That is not comfort. That is endurance. That is discipline. That is the U.S. Navy. And now you know how aircraft carrier crews survive 50-degree heat inside steel walls at sea, not because the environment gets easier, but because the people Aboard the ship refused to quit.